Hello and welcome. Today we're going to continue reviewing our SAT Practice Test 2, the math section. We're going to finish the calculator section in this video by doing 8 gridded response questions. We've done 5 questions at a time for the other multiple choice questions, but here we're going to do all 8 in one stretch. Be sure to check out those videos if you haven't seen them yet, and as always, if you like these videos or find them informative, be sure to like and subscribe. Let's get started. A coastal geologist estimates that a certain country's beaches are eroding at a rate of 1.5 feet per year. According to the geologist's estimate, how long will it take in years for the country's beaches to erode 21 feet? Well, the rate of erosion is at 1.5 feet per year, and we need to erode 21 feet. The time taken is 21 over 1.5, or 14 years. Pretty simple. Move on. If h hours and 30 minutes is equal to 450 minutes, what is the value of h? Well, h hours and 30 minutes is 60h plus 30 minutes. So 60h plus 30 equals 450, 60h then equals 420, and h equals 7 hours. Again, not much to it. Let's keep going. The xy plane, the point 3, 6 lies on the graph of the function f of x equals 3x squared minus bx plus 12. What is the value of b? As always, in these gridded response questions, they're pretty simple. You just need to know to do the right steps in order. So again here, we know that y equals f of x. So 6 equals 3x squared minus bx plus 12 when you plug in x equals 3. And you're going to end up with 39 minus 3b equals 6. So 3b equals 33 and b equals 11. Right? Not much to it again. Just make sure you know what you're doing. Number 34. In a semester, Doug and Laura spent a combined 250 hours in the tutoring lab. Doug spent 40 more hours in the lab than Laura did. How many hours did Laura spend in the lab? This seems to me like it's simply a question with a lot of words that we need to translate into some algebra, and from there it's probably going to be pretty simple. Number of hours that Doug spent is D. Number of hours that Laura spent is L. Total hours is 250, so D plus L equals 250. And Doug spent 40 more hours in the lab than Laura, so D equals L plus 40. So that means that D plus L, which is L plus 40 plus L, equals 250. So 2L equals 250 minus 40, or 210. And then L would be 105 hours. That's how much Laura spent in the lab. Again, we just need to be able to convert the words into numbers into algebra, and from there the problem is a piece of cake. Number 35. Jane made an initial deposit to a savings account. Each week thereafter, she deposited a fixed amount into the account. The equation above models the amount A in dollars that Jane has deposited after T weekly deposits. According to the model, how many dollars was Jane's initial deposit? Well, Jane's initial deposit is the same as the total money she has after 0 weekly deposits, right? At the beginning, before she's deposited anything per week, she just has that initial amount, the initial deposit. So we can set T equals to 0 and solve. T equals to 0, then A equals 0 plus 15, or $15. So the initial deposit was $15. Alright, let's move on. Number 36. In the figure above, point O is the center of the circle. Line segments LM and MN are tangent to the circle at points L and N respectively, and the segments intersect at point M as shown. The circumference of the circle is 96. What is the length of minor arc LN? Well, let's see what we can do with this. Well, since OLM and ONM are tangents, they're 90 degrees, right? Tangents are always 90-degree angles. So LMN is given as 60 degrees, so OLN is 120 degrees. Or no, LON is 120 degrees, since the angles of a quadrilateral always add up to 360 degrees. So 120 degrees is that central angle LON, and it's a third of the circle. So LN is a third of the circumference, or 96 divided by 3, 32. So the length of minor arc LN is 32. Alright, let's see what we have here. A botanist is cultivating a rare species of plant in a controlled environment and currently has 3,000 of these plants. Population of the species that the botanist expects to grow next year and next year can be estimated from the number of plants this year and this year by the equation below. N next year equals N this year plus 0.2 times N this year times 1 minus N this year over K. And the constant K in this formula is the number of plants that the environment is able to support. If you're in a calculus class, you might recognize this as being a logistic model. Of course, you don't need to be in a calculus class to understand this. It's kind of simple once you think about it. right? They're giving us all the information we need. We just need to be able to use it algebraically. According to the formula, what will the number of plants be 2 years from now if k equals 4,000? Well, k equals 4,000, then we can just rewrite this to be n1, right? So the plant 1 year from now is n1 equals n0, which is right now, plus 0.2 n0 times 1 minus n0 over 4,000, which is going to give n1 equals 3,150, since n0 equals 3,000. Well, we can do the same thing, setting n next year as n2 and n this year as n1. And then we get that n2 equals n1 plus 0.2 n1, 1 minus n1 over 4,000. And we get that n2 equals 3,284, right? So 3,284 is our answer. Let's keep going. This is the last question of this set, the last question of the calculator section. After this, we'll go to the non-calculator section in math. Let's see how we do on this. We have the same prompt, the same formula as above, but we're told that the number of plants will increase from 3,000 this year to 3,360 next year. They want an increase of 360. Well, they're asking us how many plants can the modified environment support? So what is K? Well, 360 equals nn plus 1 equals nn plus 0.2 plus nn times 1 minus nn over k. Right, this is just a rewrite of the formula. And since nn equals 3,000, the difference is going to be 360. That difference is going to be the 0.2 nn times 1 minus nn over k. So that means that 0.2 times 3,000 times 1 minus 3,000 over k equals 360. So 1 minus 3,000 over k equals 0.6. Then k equals 3,000 over 1 minus 0.6, which is 3,000 over 0.4, which is 7,500. So k equals 7,500. The modified environment must be able to support 7,500 plants. That is it for this section. Tune in next time when we start on the non-calculator section of this practice test number 2. But for now, I hope you enjoyed these videos, and I'll see you next time.